From EE Tech Media and All About Circuits, this is Moore's Lobby. I'm your host, Daniel Bogdanoff, and welcome to the first episode of Season 8. We're back from the break, and we have a great season lineup ahead of us. I'm genuinely thrilled to be back here with you, so let's get going. I'm here with Dr. Amar Gupta. He spent much of his career at MIT, where he's done impactful original work in multiple areas, including digital health and telemedicine, early work in AI handwriting recognition for bank checks, clip art, and has served as an advisor to the World Bank, the World Health Organization, and agencies of the United Nations. Dr. Gupta, thanks for being here today. I'm really looking forward to this.
Glad to be here.
I'm curious, how did you first get into technology and what gets you excited about tech today?
Well, I probably got excited in technology at the level of higher secondary itself, high school. Wanted to build things. My favorite toy was the Mechanoset at that point. That was the one you used to make things, assemble them together. And then my interest was so much that I directly went after grade 11 into college and went to Indian Institute of Technology, which is one of the most prestigious institutions in India. And at that point, computer science was just coming up and I wanted to specialize in it. And a number of people told me, why are you going to this field? This is like there's an automobile industry. There are people who do the design and then there's the transportation drivers. Why do you want to be the driver alone? Why don't you go into the basic sciences of it instead of the applied sciences? And I said, no, I want to go for applied sciences. So that's where it started. And my first major project, I would say, which was original, was I developed and implemented the first electronic taximeter in India, the one which could calculate the fares. That's what was my very first project in terms of innovation.
How did that one work? Was it hooked into the system? Because I can't imagine there was like a globally accessible GPS system at the time.
No, at that time it was local. It had to be installed on a taxi. And once it starts working, then you go ahead and take permissions from the legal authorities. And people asked me to apply for a patent.
Well, and you have done so much work that is commonplace today, but when you did it was just a kind of a radically new thing. I'd love to get a little bit into that in a moment, like the check cashing and telehealth. But I heard you got your start working also on calculators. And as an engineer, and I think for most of our audience, there's kind of a special place in everybody's heart for a pocket calculator. Can you tell me about that time?
Well, first of all, I should tell you that in the Indian Institute of Technology where I studied, they did not allow us to use calculators at all. So the first time I got to use it was when I left that institution. And the industry was just starting at that time. They were desktop computers. I joined actually the company DCM Data Products, which was the first one to manufacture pocket calculators in India. And I was put in the pocket calculator division in terms of design and testing. So that was my first experience in terms of these products, what they do, what they're good at, what they're not good at. And that's where I learned a lot in terms of the use of this new technology. And again, there were people who at one point would say, this is an impossible thing to do. Why are you wasting your time? And when that impossible thing became a reality, then they would just brush it aside and say, oh, what was new about it? It already existed. What did you do? It's a commonplace. And I've seen it with almost every new technology that I've been involved in, that people have ridiculed me. Example is presentation graphics. When we were doing work, my own colleagues told me, oh, this is just a thing for teenagers to waste their time doing things. It doesn't have any other application. So that's how we brush off till the time it's not there. And I really think in one area, I agree with my wife. She says that you're so far ahead of the crowd that nobody even knows you're there. That's the problem with you.
Well, it's a good and difficult place to be at times, I'm sure.
It is absolutely. I propose that we should do doctors and nurses make more mistakes at night. So in order to reduce that incidence, I said that when somebody falls ill in the US, and then the doctors and nurses who are attending to that person should be working in daytime from another continent. And I got a lot of hate mail for it, saying that I'm a traitor to the country. First, there's outsourcing in other industries, and now you want outsourcing to happen in healthcare also. What are you really doing and all? And now, if somebody goes in Atlanta to Emory Hospital at nighttime, that person is actually attended to by doctors and nurses based in Australia who are working in daytime there, and they are employees of Emory. So that is the way it has become commonplace. Now, hardly anybody will remember that this original idea came from me about 15 years ago.
So let's talk telemedicine a little bit, because I am recently a huge convert to being able to talk to a doctor from home on video, especially, my kids have an ear infection or something that's a little more routine. But you proposed telemedicine a long time ago, like you mentioned. Can you talk about how that idea and concept came to be, and kind of walk me through the timelines of how you saw that start to develop?
Yeah, first of all, I should clarify that telemedicine actually originated much before me. Um, Alexander Graham Bell, when he developed the telephone, his assistant was on the Cambridge side. Alexander Graham Bell was on the Boston side. So they were testing the telephone line for the first time, few miles between those two cities, neighboring cities. And the assistant spilled some acid on it. So Alexander Graham Bell told him what to do in order to take care of the acid. So that is the first recorded event which you can talk, which is of telemedicine, because it's using communication and it's using advice being given in medical area.
Well, and even if I may, like Morse code and the telegraph line came because the person's wife fell ill and he didn't know about it for 2 weeks and thought there must be a better way to communicate this
Right.
sort of status.
So emergencies and crises are the one to drive new innovation. Not only drive the innovation, for that innovation to be actually accepted by the society, because other than that, it's very difficult to change things. The status quo prevails. So in my case, the time I got interested in telemedicine is that we had used artificial intelligence and neural networks to be able to read checks. And a number of people in other industries approached me and said, how about using it in our industry? So we actually used that idea way back in early 90s and developed a system to read mammograms automatically. And the same concept was there, that the mammogram will be at one place, the doctor can be in another city, another state, another country. And we actually developed a prototype of it, and the functionality, some of the functions it had at that time, and I'm talking now of around 2000, so it's quite some years ago. Some of the functions are still not available on the systems which are available today in the market. We were so far ahead in what we were trying to do at that time. But when we took it to the market, nobody was interested in it, because they were saying, where's the reimbursement from? Who's going to pay for it? Unless you find somewhere to get the reimbursement, no, forget it. You're wasting your time. Don't work on it anymore. That's the kind of reaction that I got at that time to that invention. And in one sense, I would say that COVID has played a major role in getting it legitimized, especially in the US, the use of telemedicine. Because prior to it, people who were very reluctant, including my own doctor, accepted telemedicine as part of this COVID exercise.
So when it comes to telehealth, how does that play into your prior AI experience, or how did you first dip into that space?
Well, my experience was to use artificial intelligence in novel ways. This is artificial neural networks which try to mimic how the human brain works. So once we had done the work, our fundamental work was on reading the handwritten amount of checks. This is an area where the accuracies were very low. People prior to what we had done, it was only used for reading the postal zip code on envelopes, and their 60 to 65% accuracy is still good. They can use it for something, but with banks, there was no way anybody would accept that kind of percentage. So that's where we started working on it. And once we developed it, people from a number of different industries contacted us to use it, and we had to pick and choose which one we should go for. And that is the trend that I've continued since then, of choosing the industries, choosing the partner. And I may also add that at MIT, all the research which we do, almost all of it is funded by external sources. So that again influences what field you can go into. Some industries are more willing to pay for this kind of work. Some others want the work, but they don't want to pay for it. So those ones becomes difficult for me to cater to those industries. So we have applied it to a number of cases. I just gave the area of mammogram, but we also applied to different areas of medicine, different specialties. One of my students from the last class, she has developed a new bra which the lady can wear to work, and all her heart and lung measurements are taken while she's at work. She doesn't have to go to a hospital or clinic, and then artificial intelligence is used to read it. Similarly, another student has developed similar thing for dental x-rays, and he claims his dental x-ray procedures are the very best in the whole world. Nobody comes even close, the best dentist, doing it automatically with artificial intelligence. So these are the people who are doing the ripple effect of what we do in our group. And that's what is the exciting part of my job.
So I've seen some of your other talks, and you talk a lot about some of the notable students you've had, including for like many of our internet content viewers, Sal Khan from the Khan Academy. Can you tell me some of the other interesting research you're seeing or that you've overseen?
Well, first of all, I should say that when I was doing the work on check processing, one of the other early decisions that, or earlier opinions that I came up with is that unless we really tell people about our work, it's not going to become used in countries, it will not become a global standard. So it's a chicken and egg phenomenon. If I wait for it, so significant amount of our material we put in the public domain. We got a patent on some things, but a lot more we put in the public domain for people to see and all. That played a major role in nucleating this whole industry. And in fact, first country we worked with was Singapore, and then Britain accepted our thing. And in the US, it got deployed because primarily because of 9/11. That played the major catalyst role in the adoption of this technology. So there were students who were skeptical. Why am I giving away? Don't I care for money? And I used to tell them that you should think at a broader level. You should think of it whether you leave the world a better world behind you than as compared to the time you came. And they were very skeptical about that whole thing. But it's very interesting to see that Salman Khan followed that, and he's really done it in that way. And others have also taken that method of applying it to local problems, to extend it, and to do it. So those are the catalysts, I think, which played a major role in the introduction of this technology. As far as the people from my group, they have started a number of different companies, and one of them has just started his 100th startup. He's already reached that level.
That's so many.
Yeah.
I have a hard time conceptualizing what it must be like to be on your 100th startup. Let's maybe reminisce a bit and go back to when you're first starting out on the cashing check reading technology. Where were you? What were you doing? And what technology experiments got you into this space?
Well, I think that all the major decisions in my life have been made by destiny, not by me. And even my entry into this area of check processing and email reading is all, again, destiny. What happened is that whenever I deal with the sponsors, I give them an estimated cost for the work which will be done, whether it's development. And so far, I've always been able to work within the cost, so they get the sticker shock at the beginning, not at the end. So in one particular area, I got a request from a US government agency saying, what do you think of it and how much it will cost? So I did an analysis for which they paid a little work. And I wrote a recommendation which really got into problem. People did not like what my recommendation was. The recommendation was that in this area, the government agency or the government should not give money to anybody, to MIT or to anyone else. That was my recommendation for it. So they looked at it.
Why? What was the problem, and why was the answer to not do it?
The reason is that technology was changing so fast. If they invested in that area, by the time anything would have been done, it would be obsolete. Therefore, and it wasn't going to become a standard. And just by a government agency saying we want it done in this way, if it doesn't become the industry standard, it doesn't help. So that was my reasoning for it. And I explained it to people. So the criticism people had is that this is not the answer you should have given. You should have said, instead of this, you should be spending money on this or something. I said, they can always ask me the question, why should I have to tell them that? So because I was getting some of these opinions from colleagues, I said I should take some time off. So I took holiday abroad. And when I was on a holiday abroad, I get a call from a different officer from the same agency telling me, oh, we have decided to give money to you. And I said, what are you talking about? I don't even have a proposal pending with you. He said, no, your reputation precedes you. And I said, what is that supposed to mean? He said, well, you've just saved my neighboring program manager so much money. And we have been investing in new scanners, optical scanners. Every year we are spending millions of dollars. By the time it's made, better technology is available in the market, so it's a waste. So we want you to look at it. Oh, so I said, oh, so you want me to close down the program of yours? That's what you need my help on. He said, no, we want you to do honest study on what we should be doing. I said, I don't know anything about this field. They said, don't worry, you charge your time for that also for learning this subject. So that is the thing which we did. And that actually formed the backbone for the US Air Force to decide which documents to scan and computerize in which year. That is how they decided the gradual. So at the end of it, we had some money left, and So I called the program officer that we have some money left, and he says, "You are the kind of person who always creates problems. Nobody even knows how to deal with these kinds of problems. We have never had contractors who say they have money left. So is there something that you think should be done which will help us also and others also?" He said, "Yeah, the money wasn't very much." So that is how I got seed money to look at the idea of checks. And much later, some of the senior persons said that that money was one of the ones which was best used because it was the most useful thing, because that helped us deal with 9/11 problem. In the conventional system, the check actually had to flow from the place you gave it back to you. That's how it traveled by truck and plane. Because the planes were all grounded, within 3-4 days, $60 billion worth of checks got stuck in the system. So the options with the government are either to declare bankruptcy or to have everybody use digital way to communicate. That's how it got accepted at a broader stage, in a broad manner.
I had no idea that's how like electronic checks started, but it makes a lot of sense.
Yeah, the Check 21 was passed, the bill was passed soon after 9/11. And the Check 21 bill, one part of it actually refers to our work. And initially it was you just have to computerize it, and it can be in number form. And then it was reading it and all. So all that is transition essentially helped by it. And also remember that the conventional way of processing a check all around the world was quite complicated. For 8 years, I spent my winters in Arizona, my summers at MIT. So if I use my Boston checkbook and give it to a dealer in Arizona, the dealer would give it to a local bank. At the local bank, two people would read it to make sure it was read properly. Then it would go by a truck to the designated branch of the Federal Reserve Board, which is in Sacramento, California. Every check given in Arizona had to go in this manner to Sacramento. Then it would go by an airport to Boston, then to the lead bank, then to the local bank, and then given back to me. Switzerland had only one check processing center for the whole country. All checks had to come to that one center. So this was the uniform system which was there. And the cost of processing a check in the US was $1.25 per check. And 44 billion checks were processed in this manner every year, just in the US alone. And international number was close to 100 million checks. So this is the
Wow.
area where we made a drastic change in what's happening.
So what were some of the challenges of doing early character, especially handwriting recognition, which is totally different than figuring out like a typed up word?
Yeah.
Can you talk through some of the challenges you had, and is there anything you learned then that still applies today?
Yeah. The biggest challenge we had was in the US, people write checks in about 35 different ways. And in some of the ways they will write, they'll put, say, 25, which is the dollar amount, period. And then they'll put X, two other numbers, which are an underline, and then there's XX beneath it. So the cent is written much smaller than the dollar. I gave this problem, the students couldn't find any good way to read this small amounts, because even by human eyes, some of these are very difficult to read. So the students came up with a suggestion that we should ask banks that they should disregard the cent portion, just they should deal with checks only at the dollar level. None of the banks were willing to accept that. So we had to still
I
work
can
on
imagine.
it and do it. So we spent a lot of time trying to read how the thing should be done. Other problem which we had was of slant correction. And all the work in the literature prior to my work was dealing with slant correction of a whole word. So when you have a whole word, it's easier to find out what the average slant is, then you can put it back. But when you have single numbers, you can't use that process because you don't know what the slant is. And if you don't know what the slant is, then you can't really repair it. So the students came up with a blank. They didn't know what to do. I was reading a Japanese journal at that time, how it does autofocusing. And that gave me an idea. And I said, let me see whether it works here. In the US, especially, if you write a number, its height is usually more than its breadth. So what I proposed is that each of the numbers there should be rotated around its center of gravity or center of X. And wherever you get the maximum height and the minimum width, that is the way to start reading that number. And that is what is used now as the standard way of trying to straighten things out.
So we can thank camera autofocus for the ability for AI to read handwritten numbers.
Well, the camera thing came much later. It's almost a difference of around 15 years or 10 years at least to do it. At the time we were dealing with ordinary scanners which were reading that document. I had recommended to the bank that they stop having checks which have these colors at the back, and people write checks with colored pencils, which makes it much more difficult. Both should be in black. and you should boxes on it for dollars and cents, but they didn't accept it. In UK, on the other hand, the checks are written with the pence written in the same size as the pounds. So we thought it would be easier to apply this technology there. So we contacted them. And then we learned something interesting, that in the UK, the check has to be in written form. It does not say that a check has to be written on paper. So fairly recently, from the time when I met with them, a person wrote a check on the side of a sheep, took the sheep to the bank, and the bank had to honor it because it was in written form. So I said,
That had to be like performance art or something, right?
so I said, the first thing you have to do is to standardize your checks. And they asked me, they said, do you have some suggestions to give? And I gave those suggestions. And I'm totally shocked, surprised and shocked, that almost like 4 to 5 months later, they had accepted my design as the national standard for the country. So then I contacted the MIT lawyer and said, what do we get from this? Do we get royalties? And he says, you give everything away. What are you saying now that we'll get anything? You've just put it in the public domain.
So if any of our British viewers don't like the way their checks look, they can give you a call.
Yeah, things may have changed since that time, but that was the major thing which was done at that stage. Yeah. I've not kept track of that, what is happening abroad at this point in this industry.
Well, at least it wasn't a sheep, so that you have that going for you. You mentioned like pounds and cents. Is English uniquely difficult or uniquely easy? I know you've dabbled in different languages and character recognition in those.
Languages have different idiosyncrasies. In some ways, different societies have come up with ways to deal with it. Brazil, for example, you have to write the amount in numbers at 2 places, not just at 1 place. So they try to verify that what you've written actually matches with the other number as well. So different countries have a little different sense. Yes, some of the numbers which are written differently in different countries, 9 is one of them, 7 is one of them. So essentially, it means that the neural networks have to be trained with data from that country before it can start reading those checks from that country. That's what we have to really plan for.
Is there anything that surprised you in terms of types of handwriting that were really easy or really difficult to read? Because I have very bad handwriting, but somehow like my iPad still figures out what I'm trying to write.
Yeah, one of the things which I found, which I think is still interesting, is in the literature I found an example where it says, I can drink and drive. And the person writes it without taking any drink, then after 1 drink, after 2 drinks, after 8 drinks, even I can't read that thing at all, what is there. And people expect that even though humans can't do it, the machine should be able to do it. And that gets to be a problem. So again, I say that you have to do a test in a realistic environment, not in an ideal environment.
Okay. Yeah, that's fair. Yeah, it has to work in a real environment. Coming back to telemedicine, because I think healthcare is about as real of an environment as it gets. How did you first get who first came to you to talk about telemedicine and applying what you've used on checks to essentially on people, which feels like a big jump?
Well, I think that happened almost in parallel. At the time when we were working with checks, different people in different companies contacted us saying that you're doing some original work and numbers, we'll give you a challenge problem. One of the challenge problems that I received at that time was from a pharmaceutical giant. They said, we have some retail stores where a particular drug is only bought once a year. We lose money on it because the drug goes past its expiry date. We have to throw it away. So can you find a way where you can predict with your technology when the next sale is going to take place? We'll give you 4 data points for the last 4 years. I said, this seems an impossible problem. So I gave it to the students, 4 of them, asked them to work on it. Month later, they come back. We have developed a system with 80% accuracy, 85%. I said, no way, that's not possible. They said, yes, it's possible. So I put a 5th person to go through the code, asked the 4th person to look. A month later, they came back, yeah, it's all there. Say MIT developed technology, we should start a company. I said, I'm not satisfied. And till the time I'm not satisfied, I'm not going to let it go outside this building. So then I started looking at the code and I found that it was inadvertently cheating on itself the way they had written the code. So I told the students, they were very disappointed. But the interesting thing which happened from that analysis is that we were able to reduce the national inventory of that pharmacy chain of all drugs put together by 50% and still have the same probability of finding a drug in stock as before, which seems a contradiction in terms, but that's what we were able to achieve. So that was another area which became popular. We had people from banks come, can we use it for managing long and short positions of stocks and bonds, for example. Um, I got to co-supervise the first PhD student on weather prediction at MIT, again using neural networks. So we have worked in a number of different industries at that time. Medicine was one of the ones which came on very quickly, or almost before we came out with the check processing one, and that's why we were very interested. And then I took a step back and I said that they are not going to take this new technology easily. So I have to first really talk to the people, explain to them how transition will happen. So again, I wrote uh, a paper ahead of its time. I said all healthcare around the world is gradually going to use a three-pronged approach. And the three prongs of that approach are people in proximity to the patient, like a nurse or a family member; people at a distance from the patient, who can be a special medical specialist, could be in another city, another state, another country; and the third part would be computer based processing of information, computers giving you ideas. That's what I said in a vision paper at that time. And then I started working on all these things, the computer side of it, the people side of it, in telemedicine, started talking to people in different states, in different countries. And again, I got much more attention from states like Hawaii and Alaska, which have long distances. The eastern states were very, very difficult to deal with. They did not want to change anything. They were very reluctant to it. Florida, New York, Massachusetts. They were one of the ones to accept it much later. And COVID played a major role in it as compared to the states like Arizona, Alaska. So I was fortunate that during that crucial time, I got to spend 8 years in Arizona, and there I was able to work with the people in the medical college and the law college at the same time to write papers on this topic. And one of the controversial papers I wrote at that time was that all the restrictions imposed by state governments on interstate practice of telemedicine, they violate the interstate commerce clause of the US Constitution, and therefore all these laws are illegal and inapplicable. That's what I wrote with a JD student, only two authors of that paper.
Yeah, dipping into constitutional law will make you either a hero or a villain of many people, depending.
Initially, I was the villain. I got a lot of hate mail saying that I'm neither a doctor nor a lawyer. Not a lawyer. Both professions said, "What business do I have to write a paper like that?" And in 1917, 1917, before COVID took place, the Department of Veterans Affairs used my paper as the blueprint for changing the entire policy on telemedicine for the whole country. And I got a lot of compliments from a lot of people around. And in my own building, one of my colleagues comes and tells me on my face, "Amar, why did you waste your time writing a paper like this? A lawyer could have written it in half an hour, a 70-page long paper on Constitution." So we have this tendency that we try to say that our profession is the best, and we tend to disregard or play down other professions, which is really a sad part of it, and which really inhibits these new technologies and these new processes from being adopted.
We'll be back with Dr. Gupta in a moment, but this episode is sponsored by Mouser Electronics. As your design fulfillment distributor, Mouser is your authorized source for millions of components from thousands of leading brands. Come discover, design, develop. And now back to our interview with MIT's Dr. Amar Gupta. When it comes to cross-functional partnerships, what are you seeing today in the world of tech that people should be thinking about or maybe doing better if we want to kind of raise the tide for everybody?
Well, I think the best example is Hewlett Packard. Hewlett was the technical guy, Packard was the business guy. They worked as a team, and that's what I think is largely responsible for how that team worked. Yes, one or both of them were MIT alumni. I know about Hewlett because he contributed a chapter to one of my books. I don't know about Packard. And again, I think in today's world, you need somebody from the particular domain. If it's medicine, you take somebody from that medical domain. You need people with a business background. You need people with a technical background. And you also need people who can think about economic issues or business issues as well. So all these people really need to work. The technical person, the medical people, the economic person, they need to work together to do it. And that's the kind of background that I suggest people to have. And I should tell you, in Arizona, my own department people thought, they said, why do I waste my time writing on it? But both the people in law college and on the medicine side, the people in public health, they gave me appointments without my asking as full professors in their respective departments. So by time I left that university, I had concurrent appointment as full professor in 5 colleges of that university, which is a record in itself.
That's wild. So instead of like your parents wanting your kids to be like a doctor or a lawyer, now the answer is be a doctor and a lawyer.
Well, I think
That's
people should know at least elements of it in order to do it. Telemedicine reflected it, that a lot of people ask these questions of me. What is this state? What can I practice in this state? Can I not practice in this state? So we have written a lot on this area of technical issues, but we have also written about safety issues, quality issues. So those are some of the areas that we've been tackling. Just as in the case of artificial intelligence, when I basically vetoed the students from taking the drug thing and taking it outside the thing. Similarly, I feel on issues, and I basically take the same approach today, that if I'm not satisfied with that area, or if I think that we haven't done enough of safety issues and quality issues to it, then I basically delay introduction of that technology or idea around. That's what the concept I follow.
Hmm. So it sounds like, even going back to your Air Force contract, you've been not quick to say no, but willing to say no to things or to avenues of research.
Yeah, I've said no to a lot of things. Some of them I don't even want to say in an open interview like this. They are so borderline in terms of doing it. But I have said no to a number of projects which I did not think should be done in a university environment. And I've said no to them.
When someone comes to you with a project or a proposal or a topic, how do you evaluate it? Do you have, like, obviously not a full scored rubric, but what are questions you ask yourself or things you think when you're saying, do I go after this, or do we leave it behind and go to something else?
Yeah. Well, the first question I have is, can it be done by business itself? If people can do it in industry, like just a straight programming job, we will generally not take a project like that. It has to have some degree of innovation. It needs to have some degree of original thinking that has to go into it. Once that is there, we are very much willing to leverage what the company has already done internally, past work. We don't, it does not mean that we start from scratch. We try to build on what they've done, and we try to collaborate with them. Those are some of the issues we do. So, in the area of information technology, if somebody needs to use it for a new application, especially where it's not been used before, those are some of the applications we deal with. And in some cases, we deal with applications where people have looked at it before, but there's a renewed need for it. Case in point, uh, I had stopped working altogether in the area of reading information from paper because the whole industry had come. COVID comes in, and we get a lot of requests from companies saying that fewer customers are coming to our bank or to our business, fewer employees are coming to the customers are sending us letters in unstructured text, they're sending us faxes. We need technology to be able to read it with high accuracy and all. So all those things at MIT were directed to me because of my past work in it. So we essentially started working on that area. And because it was a crisis situation, we tried to do things as quickly as we can to give them accuracies higher than what was available with commercial product. And some of the companies actually worked with us to really implement the new technology, show how it works, and they served as role as models for other companies to also emulate. So here is a case where we have gone back and forth, where we were in an industry, got out of it, then re-entered that industry in a way.
Are there any projects that you did take on that you really wanted to work, but they just didn't quite come to fruition? And what did you learn from those?
Well, I think the number of failures I have probably exceeds the number of successes. Uh, there are a number of things which I feel bad about. One of the things which I proposed way back in the early 90s is that there should be global overview in the area of information technology. I had actually recommended setting up of a, a center of excellence, maybe one in a developed country, one in a developing country, to be playing the critical role as this new information technology was evolving. And I went to the first agency of the United Nations. They said, "Oh, we are a decentralized one." So I said, "How do I approach them?" They said, "Oh, you have to go and talked to all of them. So I actually visited most of those agencies, and they were all willing to do it. And I thought I'd reach success, but somehow when it came up for the final decision, they were willing to invest on it, but they said it would be easier if we do some initial work on it. And they asked for a seed money of $1 million at that point, and nobody was willing to give me $1 million. And that, I think, was the biggest failure that I felt. And that we are seeing the problems of it today, that there was no cohesive force to guide this thing. And if you see internet, even in that case, the World Wide Web was established outside government control, and MIT was given a lead role in playing in it. But those are the areas where I think their voids existed then, and the voids continue to exist today in trying to deal with such kind of issues. So I've had failures when I tell people I'm going to develop new technology and we actually do it, they're very happy on it. But when I tell people the other issues have also to be addressed, then they lose interest. And especially since we have to do work which has to be fully funded from outside, we have to be careful how much of the time we spend on this.
That's fair. That's fair. Coming back to telehealth and the specific things you've been working on there, are there any areas you've seen it working particularly well or particularly not well? You mentioned a couple states that maybe were more receptive to it, but to go a little more granular, where are you seeing success?
There are areas in which actually telemedicine outperforms conventional medicine. One may feel that there are no such areas. There are actually areas like that. One area, for example, is mental health. If you see a patient in his or her surroundings, surrounded by animals, surrounded by other things, that is a much better thing than the person coming to the office and sitting opposite your desk when you're doing the interview. So in Arizona, they applied that all prisoners will be treated exclusively through telehealth as the basis for it. And that was a case in which the prisoners were very happy and everybody around was very happy with this change which took place. Now, at the other extreme, you have cases where somebody fractures, somebody has an injury. Those kind of things, in many cases, you have to go to a hospital or a clinic because it needs somebody to touch in person. Yes, robots can come in. Yes, other things can happen. But again, that will be very difficult to do. And ironically, one such case is the basis why I wrote that controversial paper on constitutionality of laws. What happened is I was dealing with the medical school there on telemedicine, and Arizona is one of the states which had set up rural centers of excellent healthcare centers where people could go in an emergency and do it. These are crisis centers. In the US today, the chances of survival after an emergency is roughly one half in the rural areas as compared to the urban areas because of the time it takes to go to a facility. So Arizona has done a wonderful thing. And one of the doctors there said that I really think one thing I did, I cannot forget it. And I said, what is it? And he told me that a car accident had taken place on the Mexican side, about a few miles from the border. All the other people had died in that car accident except for one child. The child was allowed to cross into the US, came to this rural center. The doctor attending at the rural sector, it was her first day on the job. She didn't know what to do. And the people
goodness.
in the hospital in Tucson, they actually guided her through the whole process, and the child was saved. And he says, that day I cannot remember. So I said, why are you not doing it now on a country basis between US and Mexico? He said, what are you talking about? US and Mexico? We can't even do it with a neighboring state. I said, what is this going on? And that's what drove me to research that area where this problem is coming from. And I said, I'm going to play a role in it, in having it fixed.
It's a great cause and a very impactful cause for sure. When it comes to telehealth, telemedicine, we now have essentially a bunch of data being collected, either like natively or it can be inferred from the conversation, which to me opens up an opportunity for AI to come in. How do you see the interplay of AI and healthcare mixed with like expertise and professional experience in healthcare?
My answer is very cautious at this point. There's a lot of things which can be done, but they have to be used very carefully. When we develop artificial networks, neural networks, for example, they're trained on certain set of people. And these things are supposed to be retrained at very frequent intervals. And in reality, people keep using the same thing without retraining for an extended period of time. And that is not what they were designed for. They may actually be doing more harm than actually helping out. On one side, we have very little regulation in some of those areas, and in some cases, we have too much regulation. Different countries, different states want to get involved in the process. That's not going to lead to success if we continue with this kind of an affair. So we really need to have more consensus on these issues. We really need to have frameworks on it. Uh, we really need to find better ways of evaluating them on in some kind of a way on a neutral basis, not just from the manufacturer. Like if I have an order that offered what I mentioned earlier in the market, it might have been years for that thing to continue. Nobody would have really done it. The quality control mechanisms are very weak in the government, and so it was just a problem, a crisis which would have occurred, and that then only somebody would have taken care of it. So those are the kind of flaws which I still see in the infrastructure which exists today. And I take a case in point. I was getting a job as an endowed professor in LA. We went there. My wife had a fall at the hotel. She fractured both her wrists. The city ambulance took us to one of the hospitals there, and they said, yes, she has broken both her wrists, but we will not take care of anyone who's not our own patient. And they wanted us to go to another hospital. Another hospital would not take us. For 4 hours, it was wasted because there's a violation of federal law, state law, and local law that you're not allowed to send patients. So the emergency surgery was done 12 days later in Boston. We had to come in that state. And I've talked to people from numerous countries. Everybody has said it will never happen in their own country. There may not be a doctor on duty. That's a different thing. You may not be able to pay. They may not take it. But with the doctor available, when you are willing to pay, where your insurance was willing to pay, it will not happen. The thing which is ironic is on that case, I complained to the state authorities, local authority, and the federal authorities. And the responses that they've given me are totally absurd, the way they've done the inquiries. So this process has been done by the hospital for years in the past, and it's continuing to be done. So the corrective measures are just not there. The only way the corrective measures are implemented is through lawsuits, where somebody feels a lot of lawsuits are there. That's not the way to control some of these areas.
So that's definitely, there's a lot of challenge in overcoming kind of the state of the union, as it were, when it comes to like hospital administration and politics. What are you seeing on the technical side? How can engineers help fix some of these issues that you're seeing?
I think they'll have to have self-discipline. That's basically what it will have to be. The engineers have to be inculcated that thing, that it's their social responsibility to do this thing at their own level. If they see something is potentially wrong, they should not do it. They should not market it. They should not let it go out. Organizations should have a way internally of being able to do cross-checking on it, validation on it. And then there should be some external mechanisms. Like when I write a paper in a good journal, the top journals, it's always sent to 3 or 4 reviewers on an anonymous basis. I'm not told their identity. They have to look at it, and they are the ones who have to certify. So you have to have some mechanisms like this which have to be put in place, where people who are doing it feel safe of giving their honest opinion, and somebody really takes action on the opinions given by them. That is just not present today in many of the industries.
Hmm. So like peer review on a larger
Yeah.
scale, maybe.
Other countries have told me that if a thing against takes place against a doctor and all, what happens in Europe, within few weeks, they said the doctor would not be practicing anymore for the kind of thing which happened in your case. Here it just goes on and on. And I also complained to the Board of Registration in Medicine, and basically it became time barred because of COVID. They didn't process the case in time, and then it got time barred, and they did nothing also.
That's very frustrating. One area that one healthcare system that kind of has its own maybe set of rules in a sense is the VA. Can you talk about how you mentioned earlier the VA used your paper to set up a new system? Can you talk about the impact that telehealth has had on the VA's healthcare progress?
Well, VA has done a very good job trying to have a national model for telemedicine. Originally, it was you had to go to a VA facility, but now it was extended based on what has been done. The main issue, which I think is unfortunate, is that they had a very good system for electronic health records. It worked well. It was developed by them, and it was, in fact, I recommend it to people to use it as a national model. Australia at one point was thinking of using it as a national model. And that whole system was turned down and given to a private company. And the VA is having a lot of problem with that one that they've gotten from a private company. So again, decisions are not being made on the basis of merit. Decisions are made in a flawed way, which was really unfortunate to see in this particular case.
So as we are pushing the top of the hour here, we're almost out of time. We like to do some lightning round questions at the end of these. When you look back at your career, are there any technologies or projects that surprised you the most that they worked, or there was a development that surprised you the most?
I would say that I've been involved in several technologies which have come from almost nothing, presentation graphics being one of them, reading checks being another one. At that time, they seemed to be a very far reach, but we were able to do it. I think with dedication and focus, one is able to do it. And one should keep into account when one is developing this work that you should think of the world being the constituency that you're trying to reach, not just one country, not just one community. And that, if you start with that vision, I think it's very successful. It gives you a lot of satisfaction to see that what you've done is having an effect around everywhere. So so I can't think of any immediate area which people started working on it and they had to disband it. I've been fortunate that I'm at the leading edge and at a place where I hear of the things first. And in most cases, people are successful. Yes, there are diseases in medicine which have not been addressed fully. But again, these diseases have existed for a long time and we solve some and then new diseases have to be solved with again. So it's a cycle which goes on.
If there was a engineer in the audience listening who wanted to tackle a new and impactful project, are there any areas that you might point them to that might not be immediately obvious for them?
Well, I would say that the engineer should look at what is available in that industry and come up with innovative ideas and try to work on things where that work would be of significant value to the society, not just in terms of profit, but in terms of its use around. So I tend to judge our success based on how many people are positively affected by it. The other thing, especially in today's world, I'd like to say is that all of us bear a responsibility of being responsible for what we are doing. So that again is a thing which I think each person has to really take the responsibility to really adhere to certain principles. That's what I think is also very important.
Last question. You've worked across academia, across government, across corporations. You've been an advisor in all capacities. Can you very quickly give me kind of some pros and cons of each of those and maybe things people should watch out for if they're looking at going into one of those pillars of tech?
I worked in private industry in India. It was a very rewarding exercise. I went from a place where there were, from a college or an environment where there were 250 men and one woman in the whole class, to an environment where there were 60 women and five males. So it was a learning experience how to adjust to a different environment altogether. Then I worked for the government of India and I played a major role in the computer policy. I was looked upon as being the crazy guy who said India can become a world leader in information technology. They said, "You're totally crazy. We can't take care of our own things." And you say, India will become the world leader. So I pressed on it. And the first project they gave me was to set up a experimental center called the National Data Center. So wrote the report for it or coordinated the writing of the report. Got United Nations funding. It was set up. And that today is the National Informatics Center, which is the platform which connects all the government departments in all states of the country. That is what has become. And the computers which I was involved in trying to procure and doing it, some of the very eminent people of the world have actually been trained on it. I think that was my best job in terms of what I did in the government there, in terms of the ripple effect, in terms of the impact it's had on the global economy itself, not just India, but everywhere the ripple effect has taken place. In between, I also served as a diplomat in London. It was a short stay, and again, it had its own things on what to say and what not to say, and to answer questions from people who were all one generation older to me. Then I came to the US on a Rotary Fellowship. I thank Rotary for giving me the fellowship. And it gave me a chance to work with the students and to work on these projects which we have just discussed and described. Almost all this work was done here. And for part of this time, I was also in Arizona and New York. And that again gave me a new perspective to the problems that they were dealing with. Here, the emphasis is much more on the outstanding students. There, the emphasis was on having people across the spectrum, some bright, some not so bright. How do you cater to them? Which I think is very important. And incidentally, I should tell you on my teaching side, the courses I teach, I generally make them open to everybody from freshman year to practicing doctors. That's how I taught the telemedicine course. And fortunately, the students seem to have liked it. MIT has a system of ranking. Students rank the courses from 1 to 7. And the students ranked me as 7 in the different categories, which is unusual for a new course to get that kind of ranking. So that's what I tend to do. Even in Arizona, I taught courses which were open to everybody in all departments. So it was a very different experience from what is there. And I try to have more of this interdisciplinary work that you should look at society. That's your end customer, not just some bright organization or some leading organization. So those are some of my thoughts which I have.
I love the idea that our main stakeholder is society and not a acronym or a stock listing.
Or even a country for that matter.
Yeah.
Some of the things which we have done, meaning I really work with them that they should be in the public domain and people should be able to access them in all countries of the world. That's my group itself is very international in nature, has people from lots of countries.
Well, we are out of time, but thank you so much for being here today. This was fascinating.
Oh, I'm delighted to be here. I really appreciate your calling me, for listening to me, and also for your understanding of some of the things which are done, which have been controversial when I did that at that stage. So again, I think it was a great opportunity to talk with you and through you to the audience. Thank you very much.
That was Dr. Amar Gupta, principal investigator at MIT's Computer Science and Artificial Intelligence Laboratory. I'm so excited to be back in the swing of things here, and if you are too, please share this episode with someone you think will find it interesting, and come say hey over on the Moore's Lobby and All About Circuit's social pages. I'm Daniel Bogdanoff. Thank you for being a listener and spending your time with me, and I'll see you right back here soon.